Hello again and welcome to part 3 where we're looking at the new Brymen BM786. You'll notice that we now have 2 meters. You may recall during part 1 I was doing a basic functional test of the meter and I had it connected up to our little test box. This box is capable of outputting a high frequency square wave and it caused this meter to have some problems with the auto ranging. During part 2 I had the meter connected up to a higher voltage power supply, and again that power supply outputs a square wave, but in that case I'm able to change the bias voltage of it, and again what we saw was this meter had a lot of problems with that particular waveform. So I spoke with Brymen and they ended up sending me a second meter with an updated version of the firmware. So I've actually had this meter for some time, but I hooked it up to that high voltage power supply and I noticed that it was still having a bit of a problem with the auto range. Brymen got their engineers back involved. They did a fairly extensive test and they've sent me out a couple of ICs to update the firmware in these 2 meters. And what I've done is I've changed out the IC in the newer of the 2 meters. This is the original meter they sent me, and I've painted a silver dot in the upper left corner, so that's an easy way for you to tell the 2 meters apart. So what I'd like to do now that we have this updated firmware is go back through these problematic tests, and I also plan to run some more extensive waveform tests. But let's just start with the box. So again, let's just have a look at our original meter and let me show you the problem. So if the meter's in the DC voltage mode and we connect it up to our test box, and you can see I'll just put out a 5 volts DC and you can see the meter doesn't have any problems with that. But let's go to this high voltage square wave. Again, this should be roughly 60 volts or so, and you can see the meter reads basically 4.5 volts. And again, if we were to manually range the meter, you can see it's reading roughly 58 volts or so. And again, you can see if we go back to auto range, take away the voltage, reapply it, goes back to 4.5 volts. So let's have a look at our new meter and let's see how this meter responds. I'll tell you what, let's take our Fluke 189 and I'm just going to put this in parallel. Alright, so both meters are on DC volts. Both of them are attached to our test box. Now let's apply our waveform. And you can see they both read 59.8 volts or so. And let's just try it a couple of times. You can see it has no problems with this new waveform. Let's just try it in AC volts. And you can see 65 volts or so. And let's try AC plus DC. Should be roughly 90 volts. Both meters basically reading the same value. One of the things I had mentioned in part 1 is I had taken a small, 100 picofarad capacitor, I think it was. I placed it across the input leads of the meter and the meter started working. So let me just go ahead and we'll disconnect the Fluke now that you have an idea what these values should be. Again, because it is an AC waveform, the additional capacitance of this meter is going to make some difference, but probably negligible. So there you go, 88.2 volts. Again, this is AC plus DC. Let's go back to DC. Again, this is the problem child. And there you have it, 58.5 volts. And let's try it in AC volts, 65.7. And again, we can try it a few times. And you can see, no issues. One of the concerns that Brymen had about me swapping out the IC is that it can affect the calibration of the meter. So let me just show you a couple of resistance values. We won't go all the way through it. So this is a 100 ohm, 0.01%. Let's just short the leads out first. And you can see it's 100.03. This is a 1K, 0.1%. Let's just try our 10 meg because the meter was quite slow in that mode. Let's just see if that's changed at all. Doesn't seem to have. You can see it's got that slow downward trend. And again, this is our 150 picofarads, which was again quite slow. There you go, so 160 picofarads. Let's just try it with a 1 nanofarad. Looks good. So again, this is going to be 100 microamps. You can see it's spot on, and here's our 10 microamps. Again, spot on. So if indeed changing out the IC has affected the alignment of the meter, it's not enough where I'm concerned about doing the review. If you happen to notice that the meter is a little off during some of these tests, that's probably the cause of it. So off to my left you can see our high voltage power supply. This is connected to all three meters. They're all in parallel. The Fluke on the left is running in its DC voltage mode. The Fluke on the right is in its AC volt mode. And we have the Brymen BM786 in its DC volt mode. Let's go ahead and we'll turn on our power supply. And you can see we're putting out roughly 210 volts AC. Our DC voltage is roughly 17.2. Let's just adjust that down a little bit. You can see how smooth that is. Let's go ahead and we'll increase the voltage. You can see roughly 13 volts. And there's 42, 69, 78. Let's go ahead and crank it up. There you go, so 180 volts. Again, we can also double the output voltage. And you can see we're now putting out 412 volts or so AC. So you can see we're outputting now roughly 420 volts DC. So that's biasing this AC square wave up 418 volts. If you want, we can change this, so 164, let's just change our other meter over to DC volts. And again, we can see 164 volts or so. And likewise, we can change this meter over to AC. You can see 420.48 or so versus 8. This particular test seems to cause problems with a lot of the meters that I've looked at, not just this BM786. Talking with Brymen, I know that their engineers were running the same kind of a test against competitors' meters, and they were discovering the same thing, that there's just a lot of meters that have issues with high voltage square waves, especially as you start to bias them. So it's not an unusual problem, but in this particular case, this BM786 seemed more prone to it than the other meters. So let me just give you an example. Here we have the BM235. And what I'm going to do is turn off our power supply, and I'm going to replace our Fluke meters with the little Brymen. Again, even with this power supply, the added capacitance seems to have some effect on this test. So what I like to do is typically run no more than 2 meters on it anyway, basically to try to keep the edge rates somewhat sharp. As a matter of fact, while I'm talking about that, before we connect this thing up, let's just try it with the BM786 attached directly to our power supply, and let's see if it has any problems. Again, you can see it snaps right up, and let's try it at lower voltages again. You can see how smooth that is. Let's just try turning off the supply, turn it back on. Looks very good. Again, we'll switch it to AC volts. Let's go ahead and double it. Go back to DC. You can see how smooth that is. Let's take up the DC voltage and go the other way with it. You can see the meter's having no problems with this whatsoever. So they've done a really good job with the firmware on this. So let's go ahead and we'll reattach our BM235. And again, we're just going to place this into the DC mode. And let's turn on our power supply. And you can see both meters reading the same value. Looks really good, right? What I'm going to do is change the frequency just a little bit. You can see we're now running at 40 Hertz. That is correct. Let's do the same thing with the BM786. And you can see again 40 Hertz. So that's all I've done, is I've brought the frequency pretty much to the lower limit of what anybody's going to read. Now here in the US we use 60 Hertz for the AC line. In other parts of the world they'll use 50 Hertz. I don't think typically you'll be looking at a high voltage 40 Hertz waveform in the DC mode, but that's what we're going to do for this test So again, let's just go back to DC volts. But you can see the BM235 is displaying, 0.89 volts or so versus 52 volts on the BM786. What I'm going to do again is just disconnect one of the leads, and let's reconnect it. And there you have it. So 52 volts and 0.88. Let's try varying our voltage a little bit. We'll see if it ever snaps in. You can see it's still having a problem. Again, we're all the way up at 144 volts right now. And again, our AC voltage, 528. And again, let's try AC voltage with the little Brymen. You can see 525 or so. But the DC voltage, 0.2 volts. Let's try changing the range real quick. There you have it. So 145 volts DC. And again, let's go back to DC mode. You can see the 2 meters reading spot on. Again, to be clear, while I'm running these tests, I'm aware of these particular problems, and I'm not normally pushing the meters into these ranges that people aren't normally going to be using. But a few people had made comments that, if you run enough permutations, eventually you would find a sweet spot where any meter is going to have a problem. I don't know if that's true or not, but I will tell you that this particular meter now, after these latest firmware updates, is very robust. I mean, you can see that right here. As a matter of fact, again, we're at 40 hertz. What I'm going to do is just take the frequency up high. So again, our test box puts out roughly a 3 kilohertz square wave. What I've done is I've reprogrammed our high voltage power supply here to put out a 3 kilohertz square wave. Again, both of these meters are attached, and let's go ahead and turn it on. And you can see they're both displaying roughly 21.5 volts. Let's go ahead and look at the AC voltage. So you can see about 275, and let's look with the 235 as well. You can see there's a discrepancy here. Again, this is a fairly high frequency at 3 kilohertz, so you need to be concerned with the AC response times of the meters. As a matter of fact, if we look at frequency, you can see roughly 3 kilohertz, and we can do the same thing with the 786, and you can see again roughly 3 kilohertz. And let's go back to DC voltage with both meters, and you can see roughly 21.6 volts. Let's let them settle. So roughly 508 volts. Let's go positive. Again, that's about the limit of our power supply with these 2 meters attached. Let's try cutting the voltage in half. Again, let's look at that sweet spot. And again, let's try disconnecting our leads. We'll do that with the positive voltage applied. And you can see no problems. And again, let's go ahead and double the voltage. You can see it looks really good. So for this particular test, I would say this meter is now very robust. I would go so far as to say it's probably one of the most robust meters as far as the auto ranging is concerned. They've done a really good job with it. Just to give you an idea of what kind of a problem this power supply can cause, I know that one of the meters that the Brymen engineers were looking at was the Fluke 87V, probably because of its popularity. So on my right I have my Fluke 87V that I purchased just to repeat those transient tests. This was a brand new meter. See, the box is still sitting here with all the paperwork. I think that this was maybe 2 months old at the factory when I had purchased it. Let's just have a look. So again, all 3 meters are in parallel, attached to our high voltage power supply. Let's go ahead and turn it on. Our Fluke 87V is reading basically 11 volts versus 16.5. You can see as we turn up the voltage, we're up to 34 or so volts. Here we're up at 58. You can see the Fluke's displaying 38. Right there, it just switched over, and you can see now it's reading correct at 100.6 volts, basically the same value the other meters read. And I would imagine if we take up the voltage now, it's going to be accurate. You know, it's 406 on all three meters. Again, if we take it back down to that lower range, there's probably some spot where it's going to switch back down right there, and you can see it reads the wrong value again. Let's try going negative with it. Same kind of thing. So the Brymen and the 189 both displaying roughly 10.8, where the 87V is displaying negative 8.6. Again, we could take that up a little higher, and eventually again somewhere around 100 volts, I think. Oh, right there. So she switches back over, and it's probably correct again for much higher voltages. So 385, you know, that's close to 500 volts right there, and you can see again all three meters reading the same value. So again, this isn't a problem that's unique to Brymen. It's certainly not unique to this 786. I would imagine that most people just don't work with high voltage switching applications, and they just don't run into this problem. Again, this is something that I've run into since I started testing these meters, and again, some meters work better than others. Off to my left, you can see I have a small variable frequency drive. This is currently programmed for 60 Hertz. Both meters are again in parallel. Let's go ahead and look across two of the phases. Again, this is a three-phase controller, and you can see it's roughly 248 volts. Let's just try it in VFD mode real quick. 230, and let's try our little Brymen in VFD mode as well. See, VFD is active, and let's see if the two read the same. There you go, 230.62 versus 6. Let's try both meters in DC. This better read 0. Again, we'll set them both to auto range. Pretty much 0. Let's try across the other phase. Again, 0 volts. Obviously, if this is connected to a motor, you don't want DC voltage going through those windings. Let's display our frequency. Again, this should be roughly 60 Hertz, but it is pulse width modulated. Let's try the same thing with the 786. Interesting, so this is showing roughly 8 kilohertz or so, where the 235 is displaying roughly 60 Hertz. Now the VFD controller is programmed for 60 Hertz, but again, it's a high frequency PWM signal. Let's try changing it over to AC volts. Again, it's in VFD mode. We'll do the same thing with the 235, and now let's select the frequency. I wouldn't think this would make any difference at all, but let's just try it. So what do we get now? There you go, so 60 Hertz. So once it's in the VFD mode, it knows to enable that filter, and then we read our 60 Hertz fundamental. So it does make a difference if the meter is selected to VFD mode or not. So let's try some other waveforms. Most of my test equipment has some type of an interface that allows me to program it remotely. So I've written a LabVIEW application that programs my HP33120A ARB. The ARB is attached to a power amplifier that then connects to all 4 of these meters plus my oscilloscope. These are all in parallel. We're going to go through a small library of waveforms. For each waveform, we'll be changing its fundamental frequency. We're also going to be modulating it with various types of waveforms, and we'll be changing the modulation depth as well. So you'll be able to monitor the waveforms on the oscilloscope, and you'll also be able to compare our BM786 against a few other higher end meters, including the BM869S, the Unity UT181A, and the Fluke 189. Again, I'm trying to keep these videos fairly short. I'm sure that this video is going to be upwards of 30 minutes by now. I think we're going to go ahead and conclude part 3. My goal for this video was to show viewers that by the time the BM786 was available to the public, that the problems that I discovered in parts 1 and 2 had been resolved. So hopefully I've done enough testing with this meter now to prove that to everybody. I've not only shown that this new Brymen BM786 is very robust, I've also shown you meters like the 87V that have been trusted in the industry for many, many years have the same problem and have gone unaddressed. I'm very impressed with Brymen and their engineering staff and what they've done with this meter. It's been, 3 weeks since I received the very first one. I had contacted them the same day that I received the meter and let them know that I had seen that problem with the auto ranging. They turned around a fix for that very quickly and they sent us this second meter, and of course we found another problem with it. The reaction wasn't just to kick the can down the road. Instead, what their engineering staff does is they launch this huge investigation where they start looking at meters from competitors, including the Fluke 87V, and they try to understand how those meters behave under these same conditions. And they don't try to make this meter basically do the same old where, like the 87V has problems. They actually set out to solve the problem once and for all, where this meter now is probably one of the most robust meters I've looked at for that test. So it's just very impressive what they've done. And you contrast that with a company like Gossen. Gossen you'd think would be like one of the top tier companies for meter manufacturers. You hear a lot of good things about them. This is the Ultra. For those of you who've watched the videos for this, you know that this meter has a lot of problems. And Gossen had said that they were going to put a team together. I never heard anything more from Gossen about this meter. The last thing I knew about it was what they had done. This meter is sold under a different name now. It's no longer called the Ultra. But what's interesting about it is they kept the exact same part number. So if you look up the Ultra, it won't exist. But if you look up the original part number for it, you'll find this meter. It's just named differently. That's their marketing group's solution. It's not like Brymen where they're actually out there to solve the problems. Well, again, I think that's going to be it for this video. Hopefully that puts everybody's concern to rest. I have a lot more testing to do with the meter. I think in part 4 we'll be looking at the peak detect mode along with some of the other features of the meter. I'll probably do a tear down. I also want to check the lettering on it against some of the solvents. We have the drop test, and of course then we get on to our transient testing. So stay safe and stay tuned. Till the next video. Later.